All right, welcome you guys. Let's take a look at our chapter 3 test review. Okay, so on number 1 here, it says express in terms of I. So the very first thing we want to do whenever we see a negative underneath the radical is pull out an I and make it positive underneath the radical. Remember, we cannot square root negatives, and so we have to do this, okay? All right, and the square root of 81, well, 9 times 9 is 81. So this is going to be 9i. If you try to do the square root of negative 81 in your calculator, it's just going to spit out that there's an error, okay? Math error. But once you pull out the I and you make it a positive 81, then you can go ahead and use your calculator at that point. If let's say you're pretty bad at like your times tables, then you can always come here. Or if it's a difficult one, right? You can always come to your calculator once that negative is removed. All right, so let's go put this in. See what my math lab says. Great. Okay, so not too bad. Just move that negative, get rid of that negative sign and put an I out front. All right, let's take a look at number 2. Okay, so for number 2, you want to take whatever's in front of the parentheses and you want to distribute it. So let me go ahead and write this out just so I can write on top of it. So in front of the parentheses is really a 1, and here a negative 1. So we're going to go ahead and multiply by 1, which we know multiplying by 1 doesn't do anything. So this one's going to stay exactly the same. If you want to, you can just basically get rid of the parentheses in that. Now over here, though, we're distributing a negative 1. So a negative times a positive equals a negative, and a negative times a positive equals a negative. So it's just basically going to change the signs on everything that's in the parentheses behind it. All right, so from there, we're going to combine like terms, and we're not going to do it in just any old way. Remember that we want our answer to be in A plus BI form. So I'm going to start with the constants here, the real numbers. We got 14 minus 8, which is 6. And then I'll do the imaginary part of the complex numbers. Then I'll do the i's. So 8i minus 5i is going to get us 3i. And we have to type it in this way and in this order because the directions said so. So I think it would mark you off if you put 3i plus 6. But let's go ahead and put this in. You know what? Let me tinker around and see if it does mark us off with 3i plus 6. Let's see what it says. Yeah, I knew it would. Okay. All right. So just kidding. 6 plus 3i. That's how we want to do it. Now it should be good. Awesome. All right, let's take a look at number 3. Okay, so number 3. It wants us to multiply on this one. So we're going to FOIL, just like if these were a binomial with x, okay? So we're going to do the first in each parentheses. So negative 3 times 4 is negative 12. Then we'll do the outside. So negative times a negative is a positive. And 3 times 8i is 24i. Then we'll do the inners, which is 9 times 4, so 36i. And then we'll do the last. So a positive times a negative equals a negative, and 9 times 8 is 72. So this is going to be 72. Now be careful here, we're doing an I times an I, so we better have an I squared on that last term always. All right, so I'm going to go ahead and keep this, but let me combine those two like terms in the middle. So 24 plus 36, that's going to be 60. We got 60i. And then don't forget that I squared is really negative 1. So on the back end there, we are doing a negative 72 times a negative 1. So a negative times a negative equals a positive. So basically, anytime you see an I squared, it's just going to go in and change the sign. That's all it's going to do. Notice we went from a negative 72 to a positive 72 because of the I squared. So it's a nice shortcut. Sometimes you can just skip right to this step and go, okay, I'm gonna get rid of the I squared and change the sign. All right, now remember, we're trying to get things in a plus bi form. So once again, we're gonna do the real part, constants. Okay, so that's gonna get us 60, negative 12 plus 72. And then we'll bring our I down last. So now we're in a plus bi form. So let's go put it in, 60 plus 60i. All right, looking good. Problem number 4. It's actually a repeat, although sometimes people don't realize it's a repeat because it's not written in the same way. But whenever you're squaring something, that means you're going to multiply it by itself. So I have to write negative 8 plus 9i out 2 times. Once I write it like this, most students realize, okay, I have to FOIL. Okay. All right, so here we go. We have a negative times a negative. So this is a positive 64. A negative times a positive, which equals a negative. And then 8 times 9 is 72. Another positive times a negative, so a negative, and it's also 72. And then 9 times 9 is going to be 81, but don't forget I times I is I squared. So that last term better be squared. So we end up with 64, and then if we combine the imaginary parts, we're going to get negative 144i. And then let's use that shortcut. Remember what we said? We said that I squared just changes the sign on the number. So this is going to be a minus 81. Just to remind you, if you have an 81 times an I squared, you have an 81 times a negative 1. So that's why this is going to become a negative 81. All right, let's see what we get here when we do 64 minus 81. It looks like we're going to get 17 negative though. All right, and on a test, I trust myself very little, so I would be doing 64 minus 81 in my calculator if it was a test, right? We did all right. Okay, so we're going to put negative 17 minus 144i. Awesome. Okay. Pretty good here. All right, question number 5. Now we have really, oops, you know what? I'm gonna have to make this a little bigger. There we go. So this one's gonna take a bit, progressing to be probably our toughest one yet. But luckily everything we've done so far is leading us to this one. So when you have a fraction like this, what you're gonna do is you're gonna multiply by the conjugate of the denominator. So the conjugate of the denominator is going to be negative 6 plus 2i. A lot of people change both signs, but it's really only going to be the middle sign that changes. So let's see here. And we're going to FOIL. So we're going to do the firsts, then the outers, then the inners, and then the last. So I times 2i is 2i squared. Now on the bottom, you can do all of the FOILing, but you're going to see that the outer and the inner are going to always cancel each other out. So I often just do the first and the last. Okay, let's show you that. So a negative times a negative equals a positive. Now right here, what we're going to get for the outer is a negative 12i. And then what we're going to get for the inner is a positive 12i. That's no coincidence. When you have conjugates, complex conjugates, those will always be opposites of each other, and they'll cancel each other out. So that's why I said it's enough to just do the first, so the negative 6 times the negative 6, and the last, the negative 2i times the positive 2i. So a negative times a positive equals a negative, 2 times 2 is 4, and I times I is I squared. Okay, so we end up with negative 48. When we combine these, we're going to get 10i. And then don't forget I squared is just gonna change the sign on the two. And make it two. For the bottom, we have 36. And I squared is just gonna change that from a -4 to +4. Let's see what we get. It's gonna be a lot of simplifying on this one. All right, -48, take away 2. That's gonna be -50. And then 36 plus 4 is gonna be 40. Now the directions want us to put it in a plus bi form again. So what we're gonna have to do is we're gonna have to write the -50 over the 40. And then we're gonna have to write the 10 over the 40. Don't forget your I on that last term. So if we divide by 10 to both the top and the bottom on this fraction, or in other words, cancel out the zeros, we get -5/4. And if we divide by 10 here, or cross off the zeros, we're gonna get 1/4. So now we have it in a plus bi form, so we can go type it in. All right. That's a tough one. A lot going on. Not hard stuff, but the longer it is, the more likely you are to make a mistake. So this is the type of thing where I would just double check all of my math before typing it in. All right, let's try the next one, number 6. So hopefully somewhere on your note card, you have the 4 values for I to the first, which we know is just I to the second, which we know is -1, I cubed, which becomes -I, and I to the fourth, which becomes a positive 1. So because this one's the prettiest out of all of those, that's the reason why we try to express this in terms of I to the fourth, okay? So I'm gonna take I to the 28th power and try to write it in terms of I to the fourths. Now you can say, okay, well, I'm gonna have I to the fourth, and you could say, I'm gonna have that 7, oops, this is multiplied, sorry, this, a second here. How many is that? 5, 6, 7. If you added these all up, right, when multiplying, you add, then the 4 plus 4 plus 4 plus 4 plus 4 plus 4 plus 4, right? 7 times, that's going to be 28. Now we don't write it that way. It's actually a really hard, just, I don't know, time consuming way to write it. So we write that as I to the fourth to the 7th. Okay. Now, why did we express it in terms of I to the fourth? Well, because of what we said over here. Hey, I to the fourth is really 1. And that's nice because it doesn't matter what my exponent is, right? 1 to any power is going to be 1, right? 1 times 1 is 1. 1 times 1 times 1 is still 1, right? It doesn't matter how many times I multiply by 1, the answer is always going to be 1, okay? Now, I'm afraid that this was a pretty simple example, and maybe the one on your test might not be this simple. So I'm actually going to do an extra example just in case the one that gets generated for you isn't that nice. So let's say I do I to the 30th, okay? Well, in that case, I would have my I to the fourth 7 times to get me 28. But I'd still have 2 more leftovers. Now this math, like how you can get this, is you can take 30 and you can divide it by 4. You can say, okay, well, it goes in 7 times. That gets you 28, and there's your 2 leftovers, okay? Always by 4, guys, always by 4. And this is going to be the exponent on I to the fourth, and this is going to be the exponent on the leftover i's, okay? So we'll just say exponent on I. You can see that, right? The 7 was the exponent on I to the fourth, the remainder was the exponent on the leftover i's, okay? All right, now, the reason why we write it like this is because this part you can basically just cross off. We just showed a second ago, right? That is one. Go back and look. What did we get for I to the fourth to the seventh? We got one. So what does multiplying by one do? It doesn't do anything. So that's why we can just cross this off. So all we have left is I squared, which we already know is one. Okay, so basically any number I'm given, right? Any number I'm given, let's say I'm given, I don't know, 42. I always divide it by 4. And that goes into 4 once. And it doesn't go into 2, it goes in 0 times, right? And 0 times 4 is 0. So I have 2 leftovers. So this is going to be my exponent on I to the 4th. And this is going to be my exponent on I. So it should look like this. I to the 42nd power is the same as I to the 4th to the 10th. There's our I to the 40th. But we still have 2 leftovers, right? So there's our 42. And you'll always just cross this off. Now, it won't always be an I squared, you guys. Just so happens these examples I picked have been I squared, but you'll have to do the math on the leftover on the remainder, okay? All right, so hopefully that helps you out with this problem. All right, let's go put it in. Did we get 1 for the last example? Yeah, 1. Let's try it. Okay, number 7. Okay. So whenever I'm given a quadratic, where the highest exponent is 2, so you guys get all of that. I always try factoring first. So let's see if we can find factors of the last number. So things that multiply to make the last number that add up to the middle number. Well, there's not a lot of things that multiply to make 35, right? Like 7 times 5. So it must be that the negative is on the 7 in order for it to add up to -2. So just to check, -7 times 5 is -35, but -7 plus 5 is -2. So they multiplied to make the last number, and they added to make the middle number. So we're looking pretty good. So once you find those two numbers, you're going to put them in the parentheses, sorry, behind the variable, right? So it's going to be an R with a -7, that's a -7, and an R plus 5 because it was a +5. Then you just set each piece equal to 0. Each piece equal to 0. And you solve. So in order to get the R by itself over here, we're going to add 7. And then over here, we'll subtract 5. So let's go type these answers in. The directions say use a comma to separate. So I'm going to type in 7, -5. And let's see what we get. Cool. We're looking good. All right, number 8. So let's take a look at number 8. All right, use the graph to find the x-intercepts. Oh, my favorite question so far. This will take you 30 seconds, guys. Best question on the test. The only thing is, make sure you use ordered pairs, right? It's telling you right here, you better use them. So we have to get an ordered pair for this dot or that point, and you have to get an ordered pair for that one. Well, it looks like they're counting by ones. So that, since we went to the left 1 space from the origin, it's going to be a -1, 0. We didn't go up or down, so the y value must be 0. For this one, we went 1, 2, 3, 4 spaces to the right. So this one's going to be 4, 0. That's it. That easy, you guys. Okay, so -1, 0 and 4, 0. Use comma. So we better use a comma. Or also probably mark us wrong, right? We don't want to miss it for something stupid like that, right? Where we don't put the comma in. All right, easy. Everybody's going to get that one right as long as we don't have any typos. Okay, so the zeros, the zeros are, so we got -1 for a 0, and we got 4 for a 0, right? Cool. So the first time around, we use ordered pairs. The second time around, we just use the numbers. All right, number 9. I always grab the blue part because if you don't look at the blue part, you're going to miss it, not because of the math, but because of silly formatting issues, right? So I always grab it so I make sure I read it. All right, the directions say use the quadratic formula. So in order to use the quadratic formula, you have to get it into ax squared plus bx plus c equals 0 form, our standard form for a quadratic. So I'm going to have to move this 1 over to the other side of the equal sign. When we do that, don't forget, you change its sign because you subtracted it over. So anytime we cross the equal sign, make sure you change the sign on the number. Okay, now we're in that form. So we should be able to quickly see what our A, B, and C are. So it looks like our A is going to be 2, our B is going to be -5, and our C is going to be -1. So we're going to substitute these into the quadratic formula. Right. I think this might be long, so let me scooch up a little bit so I can plug these in. All right, so we have x equals -5 plus or minus the square root. Don't forget the parentheses here, or you will miss this. Always use your parentheses when you're substituting in. I know a lot of you like to use your calculator. Ooh, you don't put the parentheses on it. All over 2a, so all over 2 times 2. Let's clean this guy up. All right, we know that these two negatives will make a positive. So this is going to just be a 5, a positive 5. Right here, -5 times -5 is positive 25. And over here, we do have a negative times a negative. So it's actually going to end up being a positive right there. And then I'm just going to do 4 times 2 times 1. So 4 times 2 times 1, that's just going to be 8. Now you can do this square root part, in your calculator. So if you want to just put that part in and be like parentheses, -5, minus 4, parentheses 2, parentheses -1. See it spits out. Boom, 33. Well, yeah, if I do 25 plus 8, I will get 33. So if you're worried about the signs or maybe the number crunching, just go to your calculator. All right. Now, you might check that 33 doesn't break down, right? Remember, we're looking for doubles. Well, it's 3 times 11, and those are both prime, so we can't break down any further. Since I don't have any doubles, the square root won't break down, okay? And then, of course, our calculator, the class calculator, it will break them down for you. So if it spits the same thing back out, then it can't break down, okay? All right, let me go read how we're supposed to write this so I don't type it in wrong when it's in my math lab. Simplify your answer, type an exact answer, so no decimals, right? Use a comma to separate. You know what? I think it lets you type it in just like this with the plus or minus so that you don't have to do the commas. But let's see. Find out right now, right? Okay, so we have 5 plus or minus the square root of 33 all over 4. Oops, just kidding. My down arrow doesn't work. Okay, so tab. There we go. Let's see if it lets us do it that way. All right. I'm a little bit lazy, or I'll say I'm efficient. How about that? I'm efficient. So I'm glad it lets me put it in that way. All right, let's take a look at number 10. Use the quadratic formula to find exact solutions. Okay, so same directions. All right, so we're going to move that -4 over and make it a +4. Then we can see that our A is 5, our B is 4, and our C is also 4. I'll write out my quadratic formula. Here we go. negative b minus b squared minus 4 times a times c. Now, you don't technically have to use parentheses on a positive number, but I just do it to get everybody in the habit of it. Doesn't hurt. Doesn't hurt, but it will hurt if you don't do it on a negative. All right, so we got negative 4 plus or minus. Well, 4 times 4 is 16. And then 4 times 5 is 20. 20 times 4 is 80. Again, you can put all this in your calculator if you I think you might mess up some of the number crunching. 16 minus 80. I think that's 64, you guys. Negative though. Ooh, almost wrote the wrong thing down. Okay, so let's just go double check. 16 minus 80. Ah, we're looking good. Okay, so if I come up here, the square root of 60, well, let's bring the I out, right? So it's going to be I positive 64. And then the square root of 64, well, 8 times 8 is 64. So we got 8i. Okay, so we're going to reduce everybody by 2. Okay, so you can divide everybody by a 2. So negative 4 divided by 2 is negative 2. 8 divided by 2 is 4. And don't forget the I. And 10 divided by 2 is 5. Okay, so this is going to be our answer. All right, let's go put this guy in. What is it? Negative 2 plus or minus 4i divided by 5. All right, negative 2 plus or minus 4i divided by 5. Oh, okay, you know, I should have read the blue, huh? Type your answer in. Oh, okay, I read it now. So we do have to go one step further, you guys. I thought since it let us do it on the last problem, it was just going to let us do it on this one. But so separate it out. Put the negative 2 over the 5. And then put the 4 over the 5, right? And don't forget to shove that I off to the side so that you got your A, your B, your I. You know, I talked about reading directions and then I did not read directions. Okay, so let's go put it in. Take 2. So negative 2/5 plus or minus 4/5 I. There we go. All right. Good thing I'm doing the review because on the test, it's not going to give you that second chance, right? So I'm getting all my kinks out now, right? Getting all the things that I'm going to mess up, mistakes out of my system. All right.